Okay. Can you hear me? Okay. Thank you very much. So I'm Professor Dhaval Thakker from University of Hull, and the topic of my talk is Conversational AI, Mind the Knowledge Gap. So I wanted to set out the context before I get going with project-specific details. When I say conversational AI, in this case, we are talking about specialist domains, such as law, financial, and medical advice, so more sort of specialist advisory domains, where the common theme is, there are complex expertise required, knowledge base is required, and underlying subject knowledge frequently changes. Also, in terms of the context, when I say conversational AI, so far the work we have done could be classified under question and answering systems, but with the caveat that we don't want fixed set of questions and we don't want the fixed set of answers. So nothing is fixed or fully fixed in the system. And the next step for us is to bring more dialogue, conversation into the mix. Again, continuing with the context, I would give a little bit more context about the law domain. There has been some uptake of AI in legal domain. So there are legal technologies, a lot of work in paralegal research, due diligence, some work in contract analysis as well. But as you can see from this quote, that the uptake has been slow considering the cost, learning curve, and most often the legal implications of using technologies in the work. So this is the project which is jointly funded. It's funded by Innovate UK. I'm not sure whether you're familiar with Innovate UK or not, but it's UK's national innovation agency between the University of Bradford and AY&J solicitors. And the company and the university which are involved in here, the idea is to keep the solutions as open as possible. And that's why this portal is there to showcase those solutions for people to use it freely, which is ai-lawyer.uk. Okay, so this is a sort of a busy diagram giving you some idea of about the project overview, but it is not, if I have to simplify it, is not very different from any small to medium size company which is offering specialist advice such as immigration law. You have a small number of pre-sales team as it says on the left-hand side, which is trying to win the clients, right? But the clients needs to build the confidence. They need to clarify some of the queries in terms of their eligibility for what type of visa they can apply, whether they're eligible or not before they sign up. So there is a lot of conversations going around in that area with less number of pre-sales team. Now, anything which is need to be directed to the clients or potential clients, potential customers, that needs to be a lot of time that needs to be vetted by the solicitors or paralegal team, which is again for this sort of companies, you can imagine that their time is limited and costly as well. So you have other side solicitors and paralegal team who needs to answer those queries, but also they need to deal with customers separately, collect the clients when the potential clients become clients, collect their information, but also help them with the preparation of the casework as well. So this is where this conversational AI system we are trying to build comes in. We are calling that LILA, Legal Immigration Artificial Intelligence Advice, LILA Conversational Agent. And a lot of it is built around this big graph thing, which is called, we call it master database or knowledge graph, which I would like to talk about next. So again, this is a knowledge graph is kind of a technology which has been around for 15, 20 years. There is a whole community, research and development community, which has worked on this. It is just way of representing knowledge, the facts, and using graph structure to do that. So if you're familiar with the frame structure of AI in 15, 20 years ago, that's kind of a reincarnation of doing the same thing, but in a better way using modern languages such as XML and RDF. So everything in knowledge graph is represented as triples, concept, relationship, and objects. So SRO pairs, as we call it, SROs, triples, as we call it. So we would have something like project A has title A. So this is the level of facts you are trying to capture in your knowledge graph. Again, as I said, this technology has been there for 15, 20 years, but more recently, 5 to 7 years ago, Google has adopted it for its search and browsing, right? So this is where previously you had a search engine, search box, and you used to get number of results. Now on the right-hand side, 5, 7 years ago, you started seeing these information boxes as well. So if you search for example, late Queen Elizabeth, you would see an info back box with the photograph on the right-hand side with the relevant terms and further entities for you to browse. So that comes from the power of knowledge graph, and this is a similar type of technologies used nowadays. And this is what we are trying to use in our project as well. A lot of it is representing that as a network, as it was in the previous slide. So if we talk about this particular scenario, we are focusing on skilled worker visa category. This is a main ticketing item for this company. And as you can see, all of these bubbles you see are concepts. And they are nodes, they are concepts, and they're related to other concepts into the knowledge graph. So skilled worker visa means something. It has a semantic meaning to it. What does it mean? That it needs to have eligibility, it needs to have validity, it needs to have suitability, right? So let's drill down a little bit more in terms of what we are trying to capture here, if this thing works. Sorry, it's working. Doesn't move. Okay, suddenly moved. It's working now, thank you. So if we look at the okay, all right, it's intermittent. So in terms of the skilled worker visa category, the semantics we are trying to capture in this knowledge graph is around, as I said, suitability, validity, and eligibility. And that means slightly different things. There is meaning to it. For example, suitability is about kind of things will not make you qualify. So if you have adverse immigration history, that will rule you out. So that's what suitability means. While eligibility, as it shows in this slide, it's all about what you should have. Right? So for example, you should have a sponsorship letter from a company, you should have a job at an appropriate skill level, and there is a whole semantics and meaning to it. And also, English language requirement skill as well needs to be there in eligibility criteria. So that's a number of things which comes together. And we're trying to capture that as part of this giant graph we are trying to build, which captures all the knowledge. Again, part of that is done through knowledge elicitation through immigration experts, because not everything is captured in the rules. A lot of it is knowledge, how they've been dealing with those cases in the past and in current. But also some of that is into the immigration archives and also the current rules as well. And we are using a bit of semi-automated approach to combine both the things, knowledge we capture from the experts, but also from this archives and rule book as well, especially when we are trying to back something up with the clauses within the immigration current rule book. Right, so this is one example of backing something with the clause. So everything has a clause that helps with the explainability as well when it comes to conversational agent as well, to say that this is the clause which applies. Well, I'll show you an example of that. Okay, so it is a knowledge graph is great. As I said, Google has been using it. We have been researching it for a while. It works based with complicated data. It allows to generate. You don't have to specify everything explicitly. Things could be inferred as well. And fetching of and updating data is relatively easier. So, for example, in this case, if I need to get Okay. All right. The animation is not working as I would have expected. But if you need to fetch these, SWE skill worker, skill level requirements, there is a knowledge graph traversal which will give you all those information. So you can see that how well the knowledge could be structured. So let's look at how this is used to reach to knowledge, the conversational agent level. So you have a giant graph, captures a lot of knowledge done, and that is generated semi-automated way. So there is a bit of natural language processing happens. We are using a tool called Gate for this. It's a fantastic tool developed by University of Sheffield, but used by so many companies around the world. It's a production level system. What it works wonderfully is it works well with knowledge graph. So you can just embed the knowledge graph you have, and it helps you with entity recognition in there. As you can see, some of the examples, it is pointing to URLs from the knowledge graph. What we have in addition to using something like Gate for natural language processing and entity recognition, we use it for question templates as well. So we have an idea of what sort of questions being asked without fixing what questions they are, and we are using some sort of language analysis using something called JAPE transducer, which allows us to capture what sort of question is being asked and allows us to do the further processing as well. I'll show the whole architecture at the end. So in this case, I don't know how it works. It works when it wants to work. Okay, so as you can see here, the system architecture is a user types a query that goes to Gate that picks up the entities, but it also picks up what question template it is. It helps us to go to step 4, which is, can we generate a graph query using that information, that's entities and also what sort of question it is. That helps us to narrow down what sort of query we make to the graph, to the knowledge graph, and then that goes to the Flask API, and using answer templates, an answer is generated. So hopefully I'll be able to show you, if this thing works, so we'll skip this question, and how this works in reality. Okay, so this is the interface. Somebody types, "Hi, I am from Guyana. Do I qualify? Do I need to give an English language test?" It answers the question. It's quite fast, so I'll just try to summarize it. It answers by saying that Guyana is English-speaking country. You don't need to give English test, but because it's in the graph, the two things are related with Guyana. One is English-speaking country, but also countries which require TB certificate. Okay, so that's what it advises, even though it's not asked. It does advises that. And then it goes and, there is another answer, another question, and then another answer. That we provide the thumbs up, thumbs down to say how happy they are with the answer which is given. Then there is a further question, and at the end, I'm just waiting for... Sometimes the answers are verbose because we put the clause with it as well to provide a bit of context as well and explainability why we're suggesting what we're suggesting. Last question, can TOEFL fulfill my English language requirement? Now, if you don't know what TOEFL is, kind of IELTS, it's an English language test. It says, it answers something which is not satisfactory answer. We have expert watching over this. They say that TOEFL cannot fulfill the English language requirement. It's not applicable in UK immigration system. Canada and other countries do accept TOEFL, for example. So that's where we are. Certain question it can answer, certain question it cannot answer, but there are no fixed questions, no fixed answers. Everything is generated from the knowledge graph. So this is the evaluation we did. It didn't do so well. It can answer, this is a random questions and random answers, so it's a kind of a 50%. And most of the problems we picked up, and that is where I talk about the knowledge gap, is that it can't answer because it doesn't know about it, right? The knowledge graph doesn't know about it, so it can't answer it. So most of these 8 or 7 questions, for example, it couldn't answer, and in our larger analysis as well, is because it doesn't know about it, okay? It doesn't know about it, it can't answer it. So there is a knowledge gap here, okay? So what we come up with is how we can keep expanding this knowledge graph and do it reliably. Okay, so before I go into the detail of this, I just want to I just want to give you a bit more idea about how it is structured. So that chat you have seen, there's a sales rep and the expert being there. Sales rep raises the question which the user has asked, and the expert looks at it, and when they are not satisfied, they provide the answer to it. What we need to do is generate the facts from the answer which is provided, and if those facts are acceptable to the expert, then insert those facts into the knowledge graph so that it continuously evolves and learns from it. And ultimately, at some point, the expert doesn't need to interject because the knowledge graph knows about the new things, and then it can answer it. So there are less and less facts which needs to be clarified. This is what this diagram is trying to tell us. When the expert corrects something or answers something which the system couldn't answer, do information extraction, right? Ultimately, everything in this knowledge graph is facts. So using knowledge extraction, generate the facts, pass it to something we call semantic similarity detector. That means reduce the number of facts the expert has to look at. The idea is to show 3 to 5 facts only, not to bore them and not to lose the interest. And then once they approve it, that should be considered as a subgraph to be added to the master knowledge graph, which sanctity of it is very, very important considering this is a law domain. And that's the kind of interface. I'll just wrap up because I'm aware of the time. They could say, I agree with, this is the question, this is the answer I've provided. I'm going to agree to these 2 facts, not the third one. Just an example, I'll approve them. That needs to be generated as a small graph to be inserted into the master graph. And this is the system overall. I've talked about most of the things. Quite a lot of number of tools are used for NLP, answer generation, feedback mechanism, and semi-dynamic knowledge graph generation as well. And I'll end with a few key takeaways. We don't have a lot of data, so we can't use machine learning in this case. Also, the answers needs to be spot on. It needs to be fully backed up by the clauses and so on. That's why knowledge graph-based approach kind of works in this sort of cases, but mind the knowledge gap and consider control natural language. So when they're answering, the experts are providing that answer, we think that the control natural language might work better if we guide them the way they should answer it. Right now, it's everything free-flowing, almost free-flowing. So I'll end with that. I'll thanks people who are in the team, especially Smriti, who is patiently sitting there, our AI engineer, whose work I was happily presenting right now. So thank you very much for listening. We'll take questions, and I'll invite Smriti as well, just in case there are some. Yeah, thank you. Okay.
Have any questions? I can kick off with questions. So can you help us explain, with the knowledge that you have about these graphs, can you explain what are some of the other use cases you see for knowledge graphs? It's something I know we as a company at GoDaddy talk about. I would love to hear your perspective on that.
Yeah, I think this is, there is a lot of manual and semi-automatic work involved in this. And that effort is, I think, worth when you are dealing with a domain which requires answers which are given to the user needs to be spot on. So that's why, advisory domains such as, health. So we have seen that a lot of conversational agents which are coming, which, tries to give idea about the kind of, diagnosis, disease identification and so on directly. Chat, you might have heard about Babylon doing it in certain extent, and the answers needs to be spot on, and knowledge graph is something they might be using, we don't know, but that's a very good use case for knowledge graph. Again, finance domain as well, where knowledge needs to be properly checked, and also, it might be evolving, constantly evolving as well.
Wonderful, thank you.
Yeah, one there.
I was wondering, how do you make sure which of the facts that you showed the users are the ones that are actually relevant for them and were used by them?
You want to take that?
Thank you for the question. So like, that's actually a very good question. We are trying to work on it as much as possible. So for now, what we are doing is, as it has already been mentioned, that we sometimes show this verbose answer. So if you're asking, like if the user is asking a question, we might show them, so if it is about Australia, we might show them few, like 5 different facts, but maybe only 2 facts were relevant for them. So our idea as of now is that even if we show them 3 or 4 extra facts, at least those 2 facts should be relevant to them. And then we have planned a few rounds of testing. So that's how we are going to go forward and, try to reduce the size of the answer. But for us right now, the priority is to at least show them the right answer. And yeah, even if it is like a bit longer, it should be relevant to them. Yeah.
The main thrust here is if you use semantic similarity, because if your subject are the same or similar, or your predicate and object. So the fact is always represented as subject, relationship, and an object. Anything could be represented in these three triplets. If you find the similarity between those pairs, then you will reduce the number of facts you are showing to the user. And I think if you get better with that similarity matching, your number of facts will be reducing. So that's where the focus is at the moment. I didn't show it there, but I think we are getting it there 75% of time with the semantic similarity. But I think that's still not enough, because some cases it's showing, there was a case where it was 300 facts which were generated. So that's just clearly too much. We don't show that, but 75% of time it's 5 or less facts we are able to show.
Yeah, that's a work in progress. That is what we are currently working on.
There was a question there. There is time.
So I have a question about the regulations and what is the current state of regulations. So if there are any legal consequences to any advice that this system or a similar system gives, so whose responsibility is that, and how does that work?
I think that's a very good question. I think the lawyers are highly regulated, as you would expect. There is insurance which comes into play as well. So anything they are giving advice that needs to be covered by insurance. I don't think that covers AI systems as far as I know. There are rules and regulations around it. The way we are tackling into this ambitious project is that we do not open this directly to the users. Right, so the pre-sales people are involved capturing the queries of the customers, right, potential customers, and they are the one which are asking to, in this conversational agent, to the solicitors and the paralegal team, right? But before they answer, the conversational agent can answer, and they are always there to correct it. So there is no direct interaction with the end user. If you know what I mean. So that's kind of how we are dealing with this. But I think there are complications around just opening this to directly to the users, which is probably beyond my level of expertise to understand that. Yeah. Okay.
All right, thank you guys so much. That was wonderful and very insightful.